An electric furnace operating on 100 volts uses 2 kilowatts of power. Calculate I, the current in the circuit. II, the resistance of the furnace. III, the cost of using it for 24 hours at Ghana City 5 per kilowatt hours. An electric furnace operating on 100 volts uses 2 kilowatts of power. Calculate I, the current in the circuit. II, the resistance of the furnace. III, the cost of using it for 24 hours at Ghana City 5 per kilowatt hours. So we are going to be solving this question today. Welcome to my channel. Make sure as you watch the video you will subscribe to my channel. Okay, all right, so let's solve the question. So the question once again is, an electric furnace operating on 100 volts uses 2 kilowatts of power. Calculate I, current in the circuit. II, the resistance of the furnace. And then III, the cost of using it for 24 hours at Ghana City 5 per kilowatt hours. Okay, so first of all, let's write our data down. So we have voltage V, and it's equal to what? 100 volts. Then we have power P, that is also equal to what? 2 kilowatts. So we move on with the solution. Solution I. We know that power is equal to what? V times I. V is what? Voltage. And then I is what? Current. So power P is equal to voltage times current. V times I. And we are to solve for what? The current in the circuit. So we transpose this formula to make I, which is the current, the subject. And that is going to be I equals P over V, power over voltage. Current is equal to power over voltage. I is equal to P over V. So let's substitute the values to solve for I, which is the current. So we have 2000, which is the power, over 100, which is the voltage. So when you divide 2000 by 100, we are going to get what? 20, and it's in amps. Current is in amps. Okay, so 20 amps. So solution I, the current I is what? 20 amps. So let's move on with solution II, and we are to calculate for the resistance of the furnace. Okay, so R, which is the resistance, is equal to what? V over I. V is what? Voltage, and then I is what? The current. Okay, so when we are to substitute the values, we have V to be what? 100, and then I to be what? 20. That is what we just calculated here. Current 20 amps. So V over I. V is what? 100 over the current, which is what? 20. So when we divide 100 by 20, we are going to get what? 5 ohms. Resistance is in ohms, so 5 ohms. So solution II, the resistance of the furnace is what? 5 ohms. I hope you are following the steps. Please make sure you subscribe to the channel. Make sure you share the videos. Okay, so let's move on with the solution I. And we are to calculate for the cost of using it for 24 hours at Ghana City 5 per kilowatt hours. Okay, all right. So solution I. We know that the electrical energy is equal to what? The power consumed times time. Electrical energy is equal to the power consumed times time. And the power consumed is what? 2 kilowatts. 2 kilowatts. And the time is also what? 24 hours. So when you multiply 2 by 24, we are going to get what? 48. And it's in what? Kilowatt hours. 2 kilowatts times 24 hours is going to give us what? 48 kilowatt hours. So the electrical energy is equal to what? 48 kilowatt hours. I hope you are following it. All right, so let's now calculate for the cost. So the total cost is equal to what? The electrical energy times the charge per unit. So the electrical energy that we calculated for is what? 48. And then the charge per unit is what? 5. So when you multiply 48 by 5, we are going to get what? 240 units. So the total cost is what? 240 units. Thank you so much for watching the video.